Hey students, welcome to math.serve.com. In this clip, we're going to be going over problems 34 to 37 of the Algebra 1 Common Core Regents exam for August 2016. Alright, let's take a look at question number 34. It reads, Sean incorrectly graphed the inequality negative x minus 2y greater than or equal to 8 as shown below. So this is Sean's graph. Question, explain Sean's mistake. So in order to explain Sean's mistake, we're going to try and see if the error is with the graph or with how it's shaded, okay? Now, before we start, something we'd like to recall are the different effects on linear inequalities. Now, before you can determine where to shade, it's always necessary or beneficial to put the inequality in slope-intercept form. Okay? So when you put it in slope-intercept form and you have less than, your line is going to be broken and you're going to shade down. If it's greater, you have a broken line, you shade up. If it's less than or equal to, you have a solid line, you shade down. And if it's greater than or equal to a solid line, and you shade up. Okay? So let's see what the situation is here with this inequality. Negative x minus 2y greater than or equal to 8. We're going to place this in slope-intercept form, basically get y isolated. To do that, we're going to add x to both sides and then divide by negative 2. So let's go ahead and add x to both sides of the inequality. We'll have negative 2y is greater than or equal to x plus 8. To get y isolated, we're going to divide both sides of our inequality by negative 2. So what does that give us? We will have y. Now what's the inequality going to be? Is it going to remain greater than? Whenever you divide by negative, you have to switch the orientation of your inequality to less than or equal to negative 1/2 x plus divided by minus is minus 4. Okay? So for this line, the slope is going to be negative 1/2. And we're going to start graphing from negative 4. Okay? So you have a y-intercept of negative 4, and then you fold 1 and run 2. So we can see that the line is correct, is a solid line, but we have a less than inequality. What does a less than inequality mean? That means that you have to shade below the line. But what did Sean do? He shaded above. It appears as though he forgot to switch the inequality when he divided the inequality by a negative number. Alright? So let's go ahead and write down what Sean's mistake is. Sean's mistake is that he shaded the top of the line instead of the bottom. Okay? Instead of the bottom, since the inequality is what? The inequality is less than or equal to. So because of that less than component, you have to shade the bottom. The equal to means that the line is going to be solid. Now for the second part of 34, we have to graph the inequality correctly. Okay? So we have y is less than or equal to negative 1/2 x minus 4. So remember your y equals mx plus b equation. We talked about this earlier. Our m, the slope, is going to be negative 1/2. Okay, that means we're going to fold 1 and run 2 starting from our y-intercept of negative 4. Let's go ahead and graph that. So what we're going to graph first is the y-intercept 1, 2, 3, 4, negative 4. Okay, whenever you're graphing lines or linear inequalities, you always start with the y-intercept, -4. We're going to rise -1, 1 unit down, and run 1, 2. That's the second point that defines our linear inequality. So we will have, since we have less than or equal to, um, the graph, the line will be solid, and we'll shade the top, okay, shade the bottom. Okay, so the line will be solid, and the bottom will be shaded or below. Okay. Alright, so let's go ahead and draw our solid line through these 2 points. And then the direction of the shading will be downwards. So just draw lines like this, nothing too fancy, and that will satisfy the requirement. Alright, let's take a look at number 35. It reads, a drama club is selling tickets to the spring musical. The auditorium holds 200 people. Tickets cost $12 at the door and $8.50 if purchased in advance. The drama club has a goal of selling at least $1,000 worth of tickets to Saturday's show. Write a system of inequalities that can be used to model this scenario. Okay, so we are going to have 2 inequalities here. The first one will involve the number of tickets sold. So let's call that the tickets inequality. And then the other one will involve the cost of the tickets. Alright, so let's deal with this one first. Let's declare our variables. So how about we call x the number of tickets that were bought at the door. So as you see, number of tickets purchased at the door. And then we're going to call y the number of tickets purchased in advance. Okay. Now, the requirement is that the auditorium holds a maximum of 200 people. So you cannot sell more than 200 tickets. This is your maximum amount of tickets. You could sell less, but you can't go above 200, so you don't exceed capacity. Okay? So the number of tickets sold at the door, if you add that to the number of tickets sold in advance, it cannot exceed 200. Basically, it has to be less than or equal to the maximum number of people in the auditorium. Basically, the auditorium's capacity. Alrighty? So, based on the information we have, number of tickets sold at the door is x. If you add that to the number of tickets sold in advance, which is y, it has to be less than or equal to the capacity of the auditorium, which is 200. Okay, so that's our tickets inequality. Now let's move on to our cost inequality. How much it costs to buy those tickets, and how much revenue will be made from the sale of the tickets. Alright, so for the cost inequality, first thing we have to remember is the formula for cost. Basically, the unit price or cost multiplied by the quantity tells you the total cost. Okay? Now, we know the unit cost for Tickets at the door is $12 each, and then tickets purchased in advance is $8.50. So if we apply that formula, we can create another inequality. But we also have some constraints attached to how much revenue the club wants to generate from selling tickets. So let's write down the equations. So we have the cost of tickets at the door. So cost of tickets at the door. That's how much money they're going to generate from selling tickets at the door, plus the cost of tickets in advance. If you combine them together, they want to have at least $1,000 worth, okay? Nothing less. So it has to be less. This income generated has to be greater than or equal to 1,000. They do not. Their goal is to hit $1,000 or more. Okay, so the combined revenue from selling tickets at the door and selling tickets in advance should be $1,000 or more. That's why we have this inequality. Okay, so cost of tickets at the door is the unit price of $12 multiplied by the number of tickets sold at the door, which is X. Cost of tickets in advance, the unit price is $8.50 multiplied by the number of tickets sold in advance, Y, and that should be greater than or equal to 1,000. Okay, so now we just combine these two to generate our system of linear inequalities, which is X plus Y less than or equal to 200. That's the inequality for the number of tickets sold. And then we have 12x plus 8.5y greater than or equal to 1,000 for our inequality representing the revenue generated from selling tickets. So there goes the answer for the first part of problem 35. Alright, let's look at the B part. It says if 50 tickets are sold in advance, what is the minimum number of tickets that must be sold at the door so that the club meets its goal? Okay, so what's the goal again? The goal, just to refresh our memory, the goal is to generate $1,000 or more. Okay, so we have that inequality, which was 12x plus 8.5y has to be greater than or equal to 1,000. X is the number of tickets sold at the door. We do not know what it is in this problem. Y, the number of tickets sold in advance, is indicated for us, which is 50. So what we're going to do is substitute these values into this inequality and solve for the unknown. So we have 12x plus 8.5 times 50. That's what you get when you substitute the value of y into the inequality. Okay, so you have 12x plus, when you multiply this out, you get 425. It's greater than or equal to 1,000. You then proceed to subtract 425 from both sides. The goal here is to get x isolated. When you subtract 425 from both sides of the inequality, that gives us 12x is greater than or equal to 575. The last step that's required to get x isolated involves dividing both sides of our inequality by 12. Our final answer is going to be it's going to be x equals 47.9. But we want whole tickets, so we're going to have to round up here. Alright, so the minimum number, so my inequality should be greater than or equal to, not equal. Greater than or equal to. So the minimum number of tickets sold at the door to reach the goal is, we're going to round up, 48. Okay, so there goes your final result. All right, let's take a look at question 36. It reads, Janice is asked to solve 0 equals 64x squared plus 16x minus 3. She begins the problem by writing the following steps. So we have the steps here. We are now to use Janice's procedure to solve the equation for x. Okay, so we're going to continue from where she stopped. 0 equals b plus 3 times b minus 1. Now we'll apply the zero product property. Alright, so we'll set both factors equal to 0 and solve for b. For the equation to the left, you subtract 3 from both sides, and you have b equals negative 3. Over here, you add b to both sides, and you end up with b equals 1. Now, if you take a look at line 1 and line 2, Janice made a substitution in order to simplify the factorization process. You have 64x squared, and then you have b squared. So let's go ahead and determine what substitution she made. We have b squared equals 64x squared. So what must b be? We'll simply take the square root of both sides to undo this square associated with the b, and then that yields b equals square root of 64 is 8, and the square root of x squared is x. Remember to root both constant and variable. So b is 8x, which means that we are not done yet. Since b is equal to 8x, we're going to substitute 8x for b in both equations and solve for x. Remember, that was the original task, was to solve the equation for x. So let's go ahead and do that. Carry out the substitution. We're going to have, for the first one, 8x equals negative 3. And then for the second one, 8x equals 1. The solution to the first one, just divide both sides by 8. Divide by 8, divide by 8. And then we'll have x equals negative 3 over 8. And then the one to the right, divide both sides by 8 also. And then you have x equals 1 over 8. So there goes the solutions for x. Alright, then the second part for question number 36, we are to explain the method Janice used to solve the quadratic equation. So what did Janice do? Janice substituted 8x for b. She substituted 8x for b, or you can say she substituted b squared for 64x squared. It's the same thing, but let's just pick one. Janice substituted ax for b in order to rewrite the quadratic in a way that simplifies the factorization process. In a way that simplifies the factorization process. Okay? Alright, let's take a look at question 37. It reads, for a class picnic, two teachers went to the same store to purchase drinks. One teacher purchased 18 juice boxes and 32 bottles of water and spent $19.92. The other teacher purchased 14 juice boxes and 26 bottles of water and spent $15.76. Question. Write a system of equations to represent the cost of a juice box J and a bottle of water W. So we're asked to write down the cost of a juice box and a bottle of water. So we're looking at unit costs here. So let's go over our formula again. We talked about this previously. If you multiply the quantity by the unit price, which is what we're going to be looking for, you're going to get the total cost. Alright, so in this problem we have the total cost for the first teacher and the total cost for the second teacher. So let's go ahead and declare our variables. They've already been declared for us here, but let's just write it again. So we're going to let J represent the unit price of a juice box. Okay, and then we're going to call W the unit price of a bottle of water, of a water bottle. So using this equation right here, we're going to set up two equations. The first one will be for teacher 1, and then the second will be for teacher 2. Okay, so for teacher 1, we're going to add the cost of juice and the cost of bottled water together. Okay, so let's go ahead and write that down. We're going to be adding the cost of juice. That's total cost of juice, okay, plus the total cost of bottled water. Let's not forget the word total. Alright, when we add that together, that will be the total spent, the total cost combined for both juice and a bottle of water. So cost of juice is unit price times the quantity, or quantity times unit price. The first teacher bought 18 boxes of juice and 32 bottles of water. Alright, so those are the quantities. Okay, so 18 is a unit, is a quantity for teacher 1 times the unit price. This is for juice, okay? 18 juice boxes, the unit price for juice boxes is J, plus, now let's talk about bottles of water. Total quantity of 32 and the unit price is W. How much did the first teacher spend on both? $19.92. Okay, let's go take a look at teacher 2. For teacher 2, how many boxes of juice did teacher 2 buy? 14, right? And the unit cost is J, as we have declared over here. How many bottles of water, 26 times the unit price W. The teacher 2 spent a total of $15.76. Okay, so if we rewrite the equation in the pretty format, it's going to be 18J plus 32W equals $19.92 for teacher 1, and 14J plus 26W equals 1576 for teacher 2. This is a system of equations that we are looking for 37, question 37A. Alright, let's take a look at the B part. It says, Kara said that the juice boxes might have cost 52 cents each and that the bottles of water might have cost 33 cents each. Use your system of equations to justify that carrots prices are not possible. Okay, so we have a system of equations. Whatever solution is proposed has to satisfy both equations in order for it to be a solution. Okay, so we're going to test equations 1 and 2, with Kara's solutions. With Kara's solutions, basically with 52 cents for juice, J equals 0.52, and W equals 0.333. If we have a true statement in both equations, then her answer is correct. If it fails any of the equations, then Kara's solution is not possible. So let's start with the first equation. Okay, let's call this equation 1 and call this equation number 2. So we're going to substitute these values into equation 1. So we have 18 times 0.52 plus 32 times 0.33. Is it equal to 19.92? That's the question. Is it? If you plug it into your calculator and do the calculations, you get 19.92 equals 19.92. Is that true or false? That is very true. Okay? So the solution has to satisfy both equations. Satisfying one is not sufficient. So we also have to test the second equation. 14 times 0.52 plus 26 times 0.33. This is what you get when you substitute your answers into, or Kara's answers into the second equation. So is this a true statement? If you plug this into your calculator, you get 15.86. Is that equal to 15.76? It's no, it's false. Okay, so what's the justification here? Kara's prices are not possible since they did not satisfy both equations. Remember, the requirement is that both equations must be satisfied. Okay, the last question, we're to solve the system of equations to determine the actual cost in dollars of each juice box and each bottle of water. So let's go ahead and do that. So equation 1, the first equation we came up with is 18J plus 32W equals 19.92. And equation 2, 14J plus 26W equals 15.76. Now when you're solving systems of equations, it's always beneficial to reduce if possible. Now if you take a look at A, B in both equations, the coefficients of the variable, you will notice that they have a greatest common factor. In both cases, they have a GCF of 2. Okay? So what does that mean? I can divide both equations by 2 to simplify my problem solving process. So divide by 2, divide by 2. That gives me a system, a simpler system, 9J plus 16W equals 9.96. Okay, and then the second one, if you divide, you have 7J plus 13W equals 7.88. Now to solve this system, we can eliminate either the W's or the J's. It doesn't matter. Let's go ahead and eliminate the J's, okay? So what I want is I want to create opposites. What is the LCD of 9 and 7? The LCD of 9 and 7 is 63, right? So I want to convert these two to 63 and its opposite, negative 63. To accomplish that, I will just simply multiply the first equation by 7. That will make this 63. And multiply the second equation by its opposite, negative 9. I'm sorry, by negative 9, which will make this negative 63. So these two will cancel out. Okay? So if you're confused as to what you want to make the coefficients into to eliminate, just find the LCD, okay? So what I did is I determined the LCD of 9 and 7 to be 63. So I said I want to make the first one 63 and the second one the opposite of that, negative 63. So when we multiply, we're going to get 63j plus 112w equals 69.72. That's the result of distributing 7 across this entire equation. The second one, negative 63j minus 117w equals negative 70.92. So now we'll just simply combine both equations. Since we have opposites with the j, they get eliminated. And we will have negative 5w equals negative 1.2. Just do that with your calculators. To get w isolated, divide both sides by negative 5. And our final answer, w, is going to be 0.24 or 24 cents. Now what's the value of j? The unit price for a juice box. To get that, we're going to substitute 0.24 for w in any equation. Let's plug it into equation 1, okay? In 1, and then we'll solve for j. So we're going to have 18j plus 32. Instead of w, we're going to plug in the value. We know what it is, 0.24 equals 19.92. And then this becomes 18j plus, if you multiply this out with your calculators, you get 7.68 equals 19.92. Let's see what we have next. Okay, then we'll subtract 7.68 from both sides of the equation. When you carry out the subtraction, you're going to have 18j equals 12.24. To get j isolated, you divide both sides by 18. And then we get the unit price of a juice box, j, as 0.68. Alrighty? So let's go ahead and write down the final answer. So each juice box costs $0.68, and each bottle of water costs $0.24 or 24 cents. Okay, so that's the answer for question 37C. Thank you so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation, just place it in the comment section below, and we'll be more than glad to support you. More clips can be found on mathgotserved.com. And don't forget to subscribe to our channel because we always update our YouTube page with tons of practice resources. Don't forget to visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.